his talk, and I request him to kindly take care of the podium and deliver his talk.
Good afternoon, everybody. I realize I'm standing between lunch, so I'll try to be relatively quick. So I'm going to talk about what could potentially happen if our voting were to leverage the internet. Now, Akamai, really what it does is it becomes relevant when you talk about the internet. And it's all very highly likely, e-voting would typically leverage the internet, especially if it's going to cater to the NRI. And what might be some of the repercussions there? And I fully expect that a lot of you are likely not familiar with Akamai. And if you're not, it's the largest distributed cloud platform in the world. And at this point, it's roughly 190,000 servers. You can read some of those there. But I think the key point to note is we don't try and solve the problems or challenges on the internet through hardware. It's all done through math. And that's really what actually, I guess, distinguishes or makes it a little different. And all of this is done through Akamai's platform, which is distributed in over 1,200 networks around the world in 90 plus countries today. And this is what we actually use to offer scale and security. And really what Akamai can bring to e-voting is performance, availability, scale, and security. And these have sort of been the themes that the previous speakers have talked about, especially the security and scale. But performance is likely a key consideration as well, especially when you look at like India, like the infrastructure that you have in India, which I'll talk about in a little bit, where performance, the ability to get good performance to all users can sometimes be a rather daunting task. For those of you not quite familiar with how the internet works, really the web as a consumer, as a user, seems very simple, but it's rather complex on the inside. So the internet is really a network of networks. So the internet is built of like 2,000 different networks. And something to keep in mind is each one of these networks has their own commercial agenda, which really means that they're not doing anything for the greater good of the community. It's all about who can actually get or increase their own profits. So very often what you see is the traffic actually gets routed in a certain way or gets sent a certain direction just because commercial agreements don't exist between networks. And really, if you're an end user and you make a request, and a typical user, a lot of you likely use Airtel, then your request is likely going to go through, as an end user, you go request something through Airtel, but really it's going to go through a convoluted path and eventually get to the server where you're trying to make a request from. So it's not really optimal, is how it is. And sometimes there can actually be an issue in the path, sort of for the scenario that I gave below. Either there was an accident or there isn't a commercial arrangement, so the traffic actually doesn't get through. And which is really where Akamai fits in. As I said, Akamai deploys on really on the networks all around the world. And Akamai has servers on each of these networks. In this case, DSL, Airtel, Verizon, whoever you have, really all around the world. And if you were to use Akamai, really what it comes down to is the end user, and that's really Akamai servers. I'm just trying to go through this animation quick. So the end user makes a request. It reaches an Akamai server that is on Airtel in this scenario. Then Akamai is going to have a server on Airtel wherever the server lies. And really, that long-haul connection between the Airtel server next to the end user to the Airtel server wherever the server is, that's actually all handled within Akamai's network, which is where we're able to do a lot of optimization, be able to add security and so on. So really, let's look at some of the challenges for the internet. So kind of what I described, I tried to get through really quick. What it results in is really inconsistent performance. And I'm sure you've all been the victims of this, where you may be getting good performance on a certain site that you're at some point in time, but you go back and try and do the same thing later, or go try and do it from a different device or a different location. The performance is really not the same. So how do you actually ensure the same performance no matter what device you're on, what operating system you're on, what your screen size is, and so on, because all of those actually make a difference in performance. And in today's world, it's really the devices that actually can be quite daunting to deal with. It's not just a web browser anymore. You know, if you actually are going to have people on their iPads, their mobile devices, and in a country like India, it actually tends to be devices that are really not as powerful. They tend to be underpowered and so on. So how do you actually create a good experience on those kind of devices? Now, Akamai handles somewhere between 20 to 30% of the world's internet traffic. So just because of that scale, really what it comes, almost every consumer-facing IP that's live hits Akamai at some point or the other. So using that information, Akamai actually publishes what we refer to as State of the Internet report. So that the data that you actually have to see over there is from the State of the Internet report from the first 3 months of this year. And this is actually just looking at performance, basically looking at global performance. And in this case, it focuses on the Asia region. And if you look at the infrastructure in India, or the performance in India, which really is where it is because of the infrastructure. So it ranks 115th globally. So the first chart on the left is the average performance. On the right is peak performance. And certainly it's somewhere about, I'd say, number 15 or so in the Asia region. So, and a lot of this really comes down to really the rural areas. A vast amount of India doesn't really have even 3G connectivity. It's still edge connectivity. Now, a lot of us live in cities, so you're quite spoiled. But if you do go to rural India, your average speed drops, and which is actually really what it's actually showing over there. So how do you actually go and address those particular needs, the needs of those users from those locations? And it's a challenge. It's not easy to cater to different kind of devices, to different kind of connectivity speeds and so on. And really it comes down to constrained networks. What do you do at peak periods where everybody wants to go watch their favorite, the TV program at 8 p.m. or 9 p.m. And that chokes really the networks, let's say the likes of Airtel and so on. And how do you actually get a good experience through those? And which is really what Akamai tries to address is through various, mechanisms of channels, is it offers scale. So some of the previous speakers talked through this, is if you were to move e-voting to the internet, one of the challenges is how do you actually deal with a large surge? How do you actually deal with spikes in traffic? Then it's about performance. So sort of the scenarios that I mentioned. It's about different devices, different connectivity speeds. How do you actually cater to users all across the world in this case? Because if you're trying to cater to NRIs, they really could be spread anywhere in the world. And how do you cater to, how do you create an experience for, let's say, a user who's sitting in Delhi, where let's assume the data center is, and somebody who's sitting halfway across the world? How do you create a good user experience for both those users? And then you likely want some intelligence on what those users are experiencing and so on. And really what Akamai is able to do is provide that scale and availability when you need it most. So I tried to find like a picture that actually shows this relatively easy. So this is actually from like in the US around the November through early December timeframe is the peak shopping period. So there's a holiday called Thanksgiving. So on this particular day is when all the sales actually go live. So if you look at this chart, the orange line actually shows the performance, and the blue line is really, really the amount of traffic. So you can see, even though the traffic keeps increasing, the performance remains steady. In fact, actually, the performance actually gets better as there's more and more traffic. So really, the similar sort of scenario situation can apply to e-voting. So when you actually open, let's say, the polls on a particular day for a certain set of users, needless to say, at certain periods of time, and maybe as soon as the poll opens, there's likelihood to be a spike. So how do you actually cater to and handle that particular spike? Which comes to a very sort of related scenario. So you may have a surge or a spike so large that your infrastructure actually cannot handle the load. What do you do in that case? Which is where something along the lines of a waiting room comes into the picture. So the idea really being to send a user to your servers or to the infrastructure only when there's actually available capacity to go and handle that particular load. So what Akamai actually is able to provide is really a waiting room where if, let's say, on the servers there's high utilization, then the user will be taken to a waiting room. And I would fully expect that most of you actually have experienced this. If you go to, let's say, a sale on a particular travel site or an airline that actually has a sale, a lot of those actually make use of this particular feature. So really, rather than turning a user away, it's a much better user experience to keep somebody just sort of waiting. They can watch a video at that point, or it depends. There's ways to customize it, but and then whenever there's actually available capacity, you actually send a user to go and do the transaction. So in this case, go and cast a vote. Now, let's switch gears a little bit from looking at performance and scale to actual security as it relates to the internet. And if you were to look at last year, it really came down to really a huge year around security issue. DDoS is certainly probably the biggest thing that we see on the internet out there, but certainly not limited to that. You can have amplification attacks, DNS attacks. A lot of these attacks were actually in India as well. So around the February and March timeframe, I think there's probably some people in this room who are familiar that a large portion of Indian sites and infrastructure was subject to some of these attacks. And I guess what's truly worrying, and again, some of the previous speakers have alluded to this as well, is the size of these attacks is actually growing. So this particular chart over here shows really the size of the attacks over the last, I think it's 10 years. And the blue one shows you in gigabits per second, the scale of the attack, and the orange bar shows million page views. So 2014, we actually saw an attack that was as large as 320 gigs per second. Frankly, most data centers in the world really are not able to handle more than 1 gigabit per second, and that's a very large data center. So, an extremely large data center actually. So how do you actually handle attacks that are of that volume? And that same attack saw page views of 270 million page views a second. So how can you actually cater to that particular scale? And it's not just the scale of the attacks. They're actually also happening more frequently. So Akamai, given what we do on the internet, we are actually under attack at any point in time, all day long. It's just part and parcel of doing business on the internet, is being subject to those attacks. But if you look at this chart over here over the last 5 years, the frequency of those attacks is actually, well, it's getting more and more frequent. And we're just midway through 2015, but I could tell you that we've already crossed the 2014 number. So it's just kind of really, I think the previous speaker pointed this as well, there's just more and more DDoS attacks, hack activity that's actually happening out on the internet. And it's not just about denial of, distributed denial of service attacks. It's also attacks are getting sneakier. They are multi-vector attacks. It's not just one vector attack that is relatively easy to handle. So how do you actually handle an attack that's actually multi-vectors, where somebody will do a large DDoS attack, but truly what they really are trying to do is SQL injections and all. So how do you catch basically those needles in a haystack is really what it comes down to. And web security isn't easy. So this particular chart looks at basically 0 days for different attack vectors and the number of days it takes to address a particular vulnerability. So what that really means is if you were to discover an attack today, and it may take anywhere from 17 to roughly, I think, 140 days or so is what that chart shows. And most organizations don't necessarily have the staff. That may not be the concern over here, but certainly when you actually have more security staff, it's much faster and quicker to go and address those. So it really comes down to how do you ensure something like this doesn't happen on that one critical day, which is where leveraging security in the cloud can actually play a critical role. So with a distributed platform, what one gets the ability to do is stop the attack where it originates. So kind of what I pointed out earlier at the very beginning of my presentation, that Akamai has deployment in 90 plus countries. Now, most of us over here are probably sitting here and thinking, well, only India is under consideration over here, and how does the rest of the world become relevant? But it actually does. Almost no attacker is going to use systems that are in the country of where they actually live or originate. They will always use bots and so on that are outside, just because the local law enforcement agencies can come catch you where you live. But you want to use vulnerable systems that are just out there on a global basis. So, which is where having a globally distributed platform plays a key role is how do you actually stop an attack that perhaps a user who's sitting in the building next door is generating, but they're using agents, say, Ukraine, Indonesia, China. These are the usual culprits with systems that are, let's say, not fully secure. So they typically is where the bots actually go originate. And it really comes down to you can actually go and stop the attack where it originates. Don't let it come to your doorstep. Because once that attack comes to your doorstep, it's kind of rather difficult to stop that. It can choke sort of the bandwidth that you actually have to come into your infrastructure. So I showed a graph that showed an attack of 320 gigs per second. But as I said, a typical data center handles roughly about a gig per second. If you bring in an attack that's 1.01 gigs per second, you're automatically going to take that particular data center offline. So it's all about preventing that DDoS attack really kind of where it originated and just not let it come in or near India, really, what it comes down to. Or the ISPs that you may be using for those of, I guess, who relate more to how the internet works. And really, I guess, securing yourself from attacks on the internet isn't just about doing it on one front. You actually have to do it on multiple fronts just because there's different kind of vulnerabilities out there. Now, your site may be one, DNS is another, and so on. There's actually different kinds of vulnerabilities, and how do you actually protect yourself from each one of those? And really, security is all about layers. So how do you actually build a layer that can actually go and address all those different kind of attacks? Because no one tool or one security layer is going to go and save you or going to go protect you. It's all about adding different layers on going and protecting yourself from one of those multi-vector attacks. So I tried to look for a case study that may be somewhat relevant over here, but this is sort of the closest that I could find is really what Akamai did with the US Census in 2010. And now the scale over here is certainly very different. The census goes over a relatively long period of time, whereas a vote might be typically cast over one day or a few days. You understand the scale's a little bit different, but kind of the advantages being the challenges that it really came down to seeing a huge surge on the day that census went live, and basically being able to scale and cater to that. The US Census was, they were attacked multiple times over the window that they were open. And their site did not go down even once. It was fully available, so how do you actually go protect yourself from those kind of, whether it be a DDoS attack, but it's usually the layer 7 attacks that are actually the ones that really truly cause damage. DDoS attacks are actually relatively simple to handle. They're not that challenging, but it's really the layer 7 attacks is how do you actually go and address some of the challenges that they pose. So, as I said, I try to get through it quick so you can get to lunch, but happy to take any questions.
Questions, please.